Hello guys and welcome back to the channel. Today I'm going to show you how to create this polymorphic outdoor bench, let's call it. And the ones that watch my channel regularly probably already seen this video where I did the same thing but with modifiers, so like with traditional modeling. And a lot of comments asked me to do the same thing with geometry nodes, and until recently that was not very easy to do, or even possible, I would say. But from 3.1 and some nodes that have been added, I've been able to do it finally. And so, as usual, I will remember you that you can download this file with this outdoor bench, and from the link in the description. It's not free, but it's just $2, and it's a perfect way to support this channel and the work I'm doing. Anyway, if you don't want to spend your money, then you can always follow along and try to recreate it yourselves. Okay, as usual, in the first part of the video, I'm going to show you how to manipulate all these parameters and what it does to this bench, and then we're going to go over the geometry node tree. Okay, let's begin just by showing you that if we go into edit mode, you will get these curve handles that you can move, and your practically this bench follows along whatever movement of the curve, so it follows the curve. That's practically what it does. Okay, so that's the first thing. Then let's see right here. So width, this is the width of the bench. You can manipulate it with this parameter here. You've got the height of the seat right here. You've got the height of the back. You've got the thickness right there. You've got the outer angle, and the outer angle is practically how inclined these legs and back are. So it can go all the way from 0 to 45 degrees. Let's put it back to somewhere around 17, okay? Then we have these three bevels. So these bevels are, let me just put them all to 0, and this is what I call a bevel. So we can have sharp edges like this, or we can have beveled edges like bottom bevel like this. This is where it gets rounded. And then we have the upper bevel, which is the one right there, right here. And then we have this inner bevel that's right here. Perfect. And then we have this crop left, right, 1, 2, and what does this do? With these, you can control the size of your backs. So right here, you can have no back, or you can have all back. And you can have, and the same thing right here. Got it. Let's keep it right. Okay, let's keep it like this for now. And then we got the subdivision. So we have like 0 subdivision, or maximum of 3 subdivisions. And so I've added these subdivision options because you'll see when we get to the booleans, it gets really, it can be really power consuming and on your PC. And so it's better to have this option for maybe just placing the bench and then setting the subdivision when you're happy with the shape. Okay, then we have the reverse, so you can reverse. Doesn't look like much here, but we actually reversed these benches. And then we have what I was talking about, the slices. So if we set the slices on, this is what you get. you get the slices, and you can set the size of the slices. So the slice thickness, you can set it bigger, and you can also change the empty space between the slices as much as you want. And this is all parametric, so whatever you do, if we change the shape of our, for example, of our curve beneath, it will change accordingly. But as you can see with the bevel, it gets really hard to edit it in real time. So I suggest to keep the subdivision at 0 until you're happy with the shape, and then just up the subdivision when you're done with it, like this. Okay, that is it. Now we're going to go through our group node. Let me just go into our geometry nodes workspace. Here I worked with this file. I worked with face orientation enabled because it was important to have all the faces facing outwards, otherwise the booleans would not work. Okay, so this is our, let me just turn off this and this. So this is our node tree. Doesn't look like much, right? Well, first things first, let's just say that this part here is the slices. So we're going to leave it for now, and we're going to come back to it later. Remember, Shift Alt is the shortcut with the Node Wrangler add-on that lets you see what comes out of each node. So if I select this node and go like this, it's gonna show me, it's gonna connect it to the group output, and I'm gonna see what comes out of this node. And we're gonna start with our curve line. So first things first, we need to, another thing I forgot to show you, I remember now, sorry, let's go back. I didn't see it. Here we have the resolution. So the resolution here, what it does, it kind of makes these backs more smooth. And why is that? And that's at the beginning of our geometry node here. This is the resolution, the count of the resample curve. That's because we use the subdivision surface modifier to smooth all these lines, you know, because without the subdivision, this is how our shape looks. So, but if we have less resolution, then the smoothness is going to be even bigger. But if we have a lot of subdivisions, then obviously the smoothness is going to be smaller. The best would be to have as small resolution as you can, because it's easier and less geometry is always better if you get the shape that you want. So I don't know, I keep it at 9 if I'm having these backs, but if I don't have backs, or if I have one identical back that runs all the way from here to here, then practically the only resolution you need is 3. But let's keep it at 9 for the sake of this tutorial. Okay, so now we start with the curve line, and this is our line. And this is the resolution resample curve that we set here. And we got our transform. And the transform is just a scale on the 099 on the x-axis. And that's because when we're going to go into our booleans, then with this 0999, we just avoid having overlapping faces. That's just like safety measure, but it doesn't do anything. And that's why we set our curve length to we set our length of this curve exactly 0.01 less than the actual curve length. So what did we do here? We just added a mesh line, a straight line that has the same length as the curve that we're gonna align our shape on. Okay. And then along this curve, we need to curve to mesh node. We need to extrude our profile curve on. And this is our profile curve. And so, sorry, but you probably think that this is all you need to do, but no, there's more. This is the curve perf profile that I created as a different node so that I can create it and work with it better. Anyway, let's go inside. Let's go out of this node now, and let's just see this plane that I created. And this one has the curve profile node enabled. So this is my curve profile node that controls the shape of our extruded curve profile. But it's not that difficult. So first we've got these spheres are just a node that I added here at the end, where I placed spheres on vertices so that I can see actually what's going on. Because as you can see, these vertices would not, I would not be able to see them if there was not something, if something wasn't instanced on them. So I'm just using this. If I mute it, this is just a profile, and that's what comes out on the other side. Okay, so how did I create this profile? So I needed something with 26 vertices, I believe, because I draw this on my paper, and I said, okay, I need a vertex here, I need a vertex here, and I counted all the vertices, and I realized I needed 26 vertices. But how do I create a closed curve with 26 vertices? I could have gone with the circle, but what did I do? I've started with the star, and I set the star 13 points, so it has 13 points on the outside and obviously 13 on the inside. And then I use the set position node to set all vertices to 0, 0, 0. So all these vertices here are just getting collapsed to 0, 0, 0 position right here. And so they're all here now. I'm just gonna move this here so that I can use it to see what's going on. Okay, so all my vertices are here now at 0, 0, 0. And then I literally moved one at a time to the place where I want it to be. So I started with the selection of vertex 0, index 0, and I offset it where I want it to be. So I don't want to go over all this that I did, because I did the same thing for every next vertex in line. See how it's being built? And then when I did the first half of it, I just did kind of a mirror of it by using the transfer attribute and the position attribute, but with the -1 on the x-axis. So I practically use all the positions of the first half of them, and then I multiplied it with this vector that gave me the same vector but with a negative x-axis, x coordinate. But to get the right order, I needed to do this. This is the half of them, 26 divided by 2, and then subtracted 12 just to get the inverse order, because otherwise they would have like they would be intersecting here. And then I transformed it to put it right there where it needed to be. And that is practically it, but I just want to show you how I connected all these values, how to control, you know, because these are the parameters that I use to control the shape of this, you know, because it works, height and thickness and all these stuff. And it's not that complicated because I connected it to the right sockets to set the position of each vertex. But one thing that I've done that maybe it was not necessary was I used also this help bench, and the ones that watch my videos know about my help nodes that I use to set the clamps, because I didn't want to, for example, if I if I didn't have clamps, then the size of my bevels would probably run inside one another. So the bevel of this, so these two vertices here that set the bevel of this, and these two here, if I set them to be too big, then this vertex would go up and this would go down, and then they would practically overlap and even pass one another, and then we would have really weird geometry. So I needed to clamp the position of this vertex not to go over this one. So that's what I did here, and then connected everything accordingly so that the value that I needed to set the position of all these vertices right here and here and here, so every vertex has its own position, would be controlled by these clamped values. So even if I go over and I set this bevel to, I don't know, 100, they would get clamped and not go over one another. And that's this node that I'm gonna just go inside a bit for you to see, but that's practically what I did. So that's only geometry, and I don't want to go into this because it's not that interesting and it's not that complicated. Okay, so let's go back to our Bezier curve. I think it was this one, right? Okay, so now let's go back to this where we left off. Was this curve profile. That was the node that I showed you before. Let's go into it again. So this one comes with the profile, and we need to use the curve to mesh to extrude this profile along this curve, and that's what happens exactly. So we extruded this profile that we control with these parameters that get connected to these parameters. So I control everything from here, and we have this extruded. The important thing that I did is not to select these fill caps. And why is that? Because after I'm going to use my subdivision surface, the modifier subdivision surface node, and then it's going to create a really weird shape here, because as you know, subdivision surface doesn't work well with n-gons, and this is obviously an n-gon. What can we do? Okay, so I left it blank. Okay, and then here I added these backs here and here. I've added back here and back here. And how did I do that? First, I wanted to find out the indices of all my vertices. And I know that my indices start from 0 to 26. So my first indices on this first profile are from 0 to 25, because I already know that there are 26 vertices here. And so the next one in line is going to be from 26 to 51. If 50, 26 times 2, yeah, 51. And so on and so on. But I wanted to know how many of them are. And I found out that with the use of attribute statistic node, just connect the geometry in, the index as an attribute, and the maximum is 233. This obviously changes if I change the resolution here. As you can see, now we have 285. And if it's 9, we're gonna have, I don't know, 233. Yeah. Okay. So this is a value that's going to be useful for moving these parts up. Okay, so I needed to move these vertices up, these right here. And how to select them was not that difficult. So this is the first thing that's important, to select those vertices. So I know that these vertices here are 10 and 11, or 11 and 10, I don't know, but these two are 10 and 11. So the next one in line, so these two are going to be 10 and 11 plus 21, and this one is going to be 10 and 11 plus 21 times 2, and so on until we get to the end of it. And that's what you do with this modulo node that returns a remainder of a division operation. So if the index is 52, this modulo will return 0, because 52 divided by 26 with the remainder of 0. But if it's 53 divided modulo of 26, it will return 1. And so all these vertices are gonna have a modulo of 10 for this line, or a modulo of 11 on this line. So with this boolean, I selected all of these here. So all these vertices here and here, but that's not enough, because for example, if I just, as you can see, if I just cut it right here and connect only this one, see, so these are the vertices with the modulo of 10 and 11. But I needed also more control, because I wanted to maybe not select these when I want to, or not select these when I want to. And I did that introducing this crop left right. So how to remove some of these vertices from the selection? Well, using, of course, the less than or greater than. So for these vertices here, I needed to use the greater than, and for these other less than. And then I added this map range nodes that get controlled by these crop left right parameters from 0 to 1, and I set it to that maximum value of indices. So whichever value of indices we have here, even if we have thousands of indices, the value of crop left right is always going to be from 0 to 1. So if it's 0, it's not select, it won't select any of them, and if it's 1, it's going to select all of them. And that is it. We did the same thing for the other side. So the other side is the other part of and here the vertices are 14 and 15, and all the modulos and all these things that Practically I did the same thing here, but okay, so I've shown you how to select them, but that's not the only thing we need to do, because selection is one thing and movement is another. So I wanted to offset them because position is not what we want, but we want to offset them, so we need to add to existing position. And what did I add? I added, simple math, tangent of this angle multiply by the height. So if this was the height, then this was the tangent of the angle, and so that's how I got to the y value, which is this value here, and the z value is obviously just the height of the back. Right. And that's the thing I did also for the other one, but here we've got the inverse movement. Okay, so now we got the shape, that's right, and then we've got the subdivision surface. That we control by the subdivision, so let's add 2 subdivisions. And now we still have our extruded shape, but we have some smooth lines, and still we have holes in it. So how do we close these holes? That's not so difficult. We just need another attribute statistic node so that we can find the values of these maximum axis and minimum axis. Of course, minimum is 0 and the maximum is the length of the curve, but anyway, we don't want to guess them. We just need to ask this attribute statistic node, and then we will delete everything but this on one side and everything but this on the other side. There are 2 different nodes because it depends on whether we want, for example, if here we had like this situation, something like this, for example, where we have a back all the way till the end, then here we're going to have two different shapes, 2 different curves, 2 different lines. So that's why we need both of them. Okay, so now here we have the shape, and here we have the 2 outlines. And we are this shape will go through all the way to join geometry here. So let's leave it a bit and let's talk about these shapes here. So first we need to fill this up, and to fill a shape, a mesh loop, we need to first connect it to, we need to convert it to a curve. So we did that with this node, and then we need to and this is a tricky thing, but we cannot use the fill curve node right away. See if we mute this one, nothing happens, because for some reason the fill curve works only on the XY plane. So first we need to unmute this, and first we need to rotate this shape on the Y plane to get it into the right position, and then we need to fill the curve, and then it's gonna jump into our XY plane. That's why we didn't need to move it from down here, but as soon as you fill curve, it's gonna go up. Okay, so what we did here, we got the fill curve here and this one here, 2 of them. And then we need to bring them back in position, so this one only gets rotated and this one also gets rotated, but then we need to move them a bit So this one gets to be moved on the end, and this is the statistic, remember? So the most further apart X value, and that's the value we need to move it. And the other one stays in place. And then we need to flip the faces on this one and flip the faces of this one to join them all inside this perfectly looking shape. And then we need to use also the merge by distance node, and this one is extremely important, and this is why until recently I wasn't able to create this shape, because without this node, this joint geometry is just faces and not a solid object, because when we merged them all, it became a solid object, and here it was just a bunch of faces sharing the same space, but not really acting like solid. Okay, so now we have our solid that we need to slice. Now we're gonna slice it. Okay, now let's go back. As you can see, I'm running it through the mesh boolean node where I'm slicing it with this. Let's see what's up here. Okay, pretty simple, don't worry about it. Just curve length again, curve line. Okay, so it's the same line. It's the same line, but this time it needs to be resampled in respect of the size of the slice thickness and the empty space thickness. So that's what we did here. So we resampled this line so that its vertices come out spaced the right amount, so that we can instance our cubes on it and create slices. But before we got to that, there is a little piece here that's delete geometry, where I deleted the first and the last vertice of that. And that's because I wanted to avoid these overlapping faces, because booleans don't work well with overlapping faces. So by deleting the first and the last vertice, I removed practically this possibility. Okay, so now we have the line, we have the vertices placed in the right position, and now we need to instance our cube objects. And of course, these cube object size is defined by the width, the height of the seat, the height of the back, and also by the empty space thickness, because that's what this value is. That's the empty space, because this is going to be cut out of it. And this is the size of the cube that we need so that it can cut through our object. And let's go back, and this is where we connect it into difference, and so now it cuts our object the way it's supposed to. Let's just lower the subdivision right now for the sake of this tutorial, so we can work peace. And obviously, if you don't want the slices, this is the switch that you need to turn off. As you can see, when it's true, it returns this mesh boolean node, and if it's false, it just passes it over him. So out of this switch node that you can control with this slice, where is it, where is it, where is it, where is it, slice yes, no, yes, no. And then the most important part, and the most important part is something that I'm not going to show you in this video, because I created a video and uploaded it a couple of days ago about this curve deform geometry node tree that I created. Let's just glimpse over it, something like that, that actually works as a curve modifier. But I'm not going to go over it because that's exactly what I did in the video that you can go check out, link in the description. And that's the last part that we need to do to finish our bench. So we need to plug our geometry, that's our curve, into this curve socket, and then it returns our shape the way we would expect it to. So if we go into our tab view, you can see that our curve is right there. And that is practically it. The last thing that was left to do was to put it up on the z-axis so that this part is on the floor where the origin point is. And that's how you do it. You just attribute statistic, you search for the lowest z value and then move it that same exact value on the z-axis. And that is it. That is practically it. So thank you so much for watching. Remember that you can purchase this file and this bench with all these nodes. Link in the description. And thank you so much for supporting this channel. And I will see you in the next one with probably another geometry node video. Bye bye.